a look at the front board. I'm going to move through these two very quickly. Angle, side, congruent to angle, side. Please circle this. We use AAS when we have two angles and one side, and the side is non-included, which means it's not in between. You have an angle, you have an angle, you have a side that's not in between. All you have to write is AAS, and ABC would correspond to FED. You could start these three in any order that you want. Just make sure that they correspond in the second.
So C always has to be
The two justifications on this page are not as obvious. So what do you think they're called? This is a theorem. I'm not going to require that you write down that it's a theorem, but when it shows up on a standardized test, it'll probably be called angle, side theorem. The same is true for HL. HL does not stand for height and length. It stands for hypotenuse and leg. This is a little bit of review. On Friday, when you were watching the video, the legs represented something in an isosceles triangle. They were the two equal sides. We're using leg again, but now it's a different definition. It's just the sides that are not the hypotenuse. When you write down sides, make sure that you actually put a symbol above the two letters. Don't just write down XZ. Put a symbol above. YZ, put a symbol above it. It's a segment, so give it a segment symbol. So this is the fifth choice we have. Take a look at the sideboard. Competing with a few conversations. Let's look up here. If you have a triangle that's not a right triangle, you only have 4 choices. If it's a right triangle, then you have 5 choices. Anytime you see a right angle, try HL. If you see a right triangle. If that doesn't work, then it could be any one of the other 4, but always try this first. Put slash marks here. That's the hypotenuse. So we have hypotenusae that are congruent. I don't know if that's right. Then we have a leg congruent to a leg. If you see that setup, then you can use HL. It's considered a theorem because it's a little bit beyond SSS. Do you remember the Pythagorean theorem? If I had a 3 here and a 5 here, what would the other side be? 4. Well, if this is 3 and this is 5, then what's that side? 4. Instead of going through the process of the Pythagorean theorem, we just say we know it's going to be the same. And that's why we write HL. So we're kind of bypassing a step, and because we're doing that, this is also considered a theorem. There's a little bit more to it, not quite as obvious. ABC congruent to, what would correspond to A? R, what would correspond to B? Q. We've got 1 slash mark here, we've got 1 slash mark here, and then P would be the last one. Side 2 at the top. This is the last time I'm going to have you write this. I want you to write down vertical angle theorem. We're going to write it a little bit more precise this time. Whenever you use vertical angles being equal, write vertical angle theorem. You can shorten it up to that, that's fine. Instead of common side, what was the property? Reflexive property. And over here, we're going to say alternate interior angles, and now we're going to start to add THM. If you see those things, jot that down. Because that's what you're going to do when we get to our congruency maze. You're going to jot down. If you put vertical angles in, like here, jot down vertical angle THM. If you have a common side, write down reflexive property. Go ahead, do these. Is there just 6 on this page? Do these 6. If you put something into the drawing, tell me why you put it in. Was it vertical? Was it reflexive? Was it alternate interior? For the first one, I try HL. I see I have a hypotenuse here equal to another hypotenuse, but do I know anything about the legs? No. Can't do HL. So then I start looking at what I have. I have an angle, and a side. How many people wrote AAS for the first one? It's not ASA because the side is not directly in between. It's AAS. They just put it in alphabetical order, Chase, for no reason at all. In number 2, I can't add anything to it. It's already got the vertical angles with the right angles right there. Try HL. Is a hypotenuse equal to another hypotenuse?
Yes.
Is a leg equal to another leg?
Yes.
You've got HL. I will leave the congruent statement to you.
Why?
Number 3, underline and circle. I'm only cutting the SR in half. QT is actually doing the cutting. Why did I put that in there?
Vertical angle.
Vertical angles. Do I have parallel lines? Which means I have a bunch of Z shapes, backwards Z shapes, so this is equal to this. Can I do a Z shape this way? So I can put 3 here, 3 here. If I look at everything that's involved here, I've got an angle, another angle, and then a side right here. I've got 2 possibilities. Or AAS. It depends on which 3 I choose. I just happen to have more things. This time I had 4 pieces out of how many? 3 plus 3? 6. So out of the 6 possibilities, I had 4 in this case. That gave me 2 choices. What's number 4? HL. Number 5, very easy to tell. SSS. I'm going to do the congruent statement for that one, because some people are getting that incorrect. If I say WVX, what corresponds to the W? D. It didn't flip, it just slid. It's a, what's that called when you slide something? Translation. And you can look at this, that's got 1 slash mark on it. This one has 1 slash mark. Therefore, W corresponds to B. What goes with V? Itself. And X goes with A. What do I have in the last one? SAS. Side, angle, side. Focus on one triangle after you put in all of your symbols.
I'd love to watch the thing.
After we start the maze.